Hello everyone, and welcome to the first video in the Chapter 2 material. We're going to cover in this video section 2.1, which is an introduction to weighted voting. So let me give you the basic setup of this chapter in contrast to the previous chapter. In Chapter 1, which we just finished, each voter had one vote. Each voter had the same weight as any other vote, right? Each voter counted the same. In Chapter 2 now we're going to change that. In Chapter 2, each voter can have a different weight from any other voter. So whereas it used to be in Chapter 1, one voter, one vote, now in Chapter 2, the paradigm is one voter, X votes. So in other words, some voters can count more than others. I can maybe have 3 votes and you can maybe have 8 votes, for example. And formally this is known as weighted voting, and your weight is the amount of votes that you get. So if I have 3 votes and you have 7 votes, your weight is 7 and my weight is 3. So this kind of voting happens fairly frequently, especially in the business world and corporations and business partnerships. But in the political realm it happens a lot too. You'll see weighted voting in legislatures, in the UN Security Council, and probably the most relevant example for you is the Electoral College, is a weighted voting system. So let's look at a few of those examples. The Electoral College itself consists of 51 voters. That's because each state is a voter and the District of Columbia is a voter, so 51 total. The weight of each voter, the amount of votes that they get, in other words, is determined by the size of the congressional delegation. So California has a weight of 55 because it casts 55 votes. North Dakota, on the other hand, has a weight of 3. It only sends 3 people to the delegation and it only has 3 votes. Therefore, California has approximately 18 times the weight of North Dakota in this particular election. So this is different from the previous chapter, right? In the previous chapter, California and North Dakota would have each just cast a single vote. But now California casts 55 and North Dakota casts 3. So California is more powerful than North Dakota. Here's a business example. Imagine a partnership that consists of 5 people. Person 1 and person 2 invest $3 million. Person 3 invests $2 million, and the other 2 people invest $1 million. When it comes for the 5 of them to make decisions, usually this is what happened. Person 1 gets 3 votes. Person 4 gets 2 votes. And person 4 and 5 each get 1 vote. Right, so the amount of votes you get is determined by the amount of money that you sunk into this. So this happens all the time in business partnerships. Okay, so let's set up the formalism of all this. So formally, a weighted voting system is any formal voting arrangement in which voters aren't necessarily equal in terms of the number of votes they control. And in this chapter, we will consider voting only on yes-no choices. And a yes-no choice is known as a motion. Okay, so things like, should we legalize marijuana? Should we raise a tax to fix these roads, etc., right? So you're going to be voting on questions with a yes or no answer, and you will either vote yes or you will vote no. So this is also in contrast to Chapter 1, where you could be voting for maybe 30 different candidates, right? In this chapter, there are only 2 candidates, quote-unquote candidates. You can either vote for yes or you can vote for no. So we will only be voting on motions in this chapter. Okay, so a weighted voting system has 3 components. The voters themselves, which are referred to as players. And the players can be individuals, but they can also be institutions or countries or whatever, like with the United Nations. And we will use capital N to denote the number of players in the weighted voting system. And we will list them with capital P's and a subscript. So player 1, player 2, player 3, so on, all the way up to player 1,000, if there are 1,000 of them. Okay, so once we have voters, we have to determine how many votes each of them gets. And the hallmark of a weighted voting system is that each player controls a certain number of votes, which, as we already said, is called their weight. And we will use W's with subscripts to denote their weights. And we will let V denote the total number of votes inside the system. So player 1 controls W1 votes, player 2 controls W2 votes, etc. And then V is just the sum of all these weights. So V is equal to W1 plus W2 plus W3, etc. up to Wn. And the last component of a weighted voting system is the quota. The quota is the minimum number of votes required to pass a motion, and we're going to use a lowercase q to denote that. And the most common standard for the quota, not quote, is a simple majority. But it can be different, right? So in the Senate, you need 60 votes to stop a filibuster. So 60 votes is more than a simple majority. And sometimes you need unanimity, in which case the quota is all the votes. So you actually need everybody to vote the same way to pass something. Here is the streamlined notation we will use to denote a weighted voting system. So I'm going to give you some examples in a second, but the main thing to be aware of is don't be intimidated by notation like this. This is just a simplified way of writing more information than you want to write. So let's just walk through this. A weighted voting system with N voters is written like this. The quota comes first. So the first thing you're telling somebody is, how many votes do I need in order for a motion to pass? And then you list the weights of the players. So the weight of player 1, which remember is the number of votes player 1 controls, the number of votes player 2 controls, etc., all the way out until the last player. And just for aesthetic reasons, we write the weights in descending order, so from biggest to smallest. Okay, so here's an example of this notation, 8:3221. So what this means is there are 4 voters. The voters come after the colon. This 3 is the weight of the first voter. That means that player 1 has 3 votes. This next number is the amount of votes player 2 controls. So player 2 has 2 votes, player 3 has 2 votes, and player 4 has 1 vote. Okay, so voter 1 has 3 votes, voter 2 gets 2, etc. So how many votes does a motion need to pass? Well, the answer to that is the number in front of the colon. That's the 8 there. So for a motion to pass in the system, you need 8 votes. Okay. Notice that 3 plus 2 plus 2 plus 1 is 8. So if you need 8 votes for a motion to pass, and there are only 8 votes in the system to begin with, then you need a unanimous decision here to pass anything. So here's another example. 4 partners decide to start a new business. They want to raise 200 grand for startup, so they issue 20 shares that are worth 10 grand each. So suppose player 1 buys 8 of those shares, player 2 buys 7 of them, player 3 buys 3, and player 4 buys 2. And suppose that 1 share equals 1 vote, and the quota is set to be 2/3 of the number of votes. So this certainly seems like a reasonable way to set up a voting system. If player 1 buys 8 shares and player 4 buys 2, player 1 has sunk more money into this than player 4 has. So it stands to reason that player 4 should have more of a say than, player 1 should have more of a say than player 4 has. Okay, so let's give the notation for this. There are 20 shares, so 20 votes in the system. 2/3 of 20 is 13 1/3, is what this is. Okay, but you can't have fractional votes, right? It doesn't make any sense to say 1/3 of a vote. So anytime you compute a quota and you get a fraction, you should just round up, okay, regardless of what the numbers are. Always round up, because if you need 2/3, right, that's what this is saying, you need 2/3 to vote. If you round this down, you will be less than 2/3. Okay, so you want to round up to make sure you really must get at least 2/3 to pass. If you don't get a decimal, you of course don't need to round, right? But if you do get a decimal, you can't have fractional votes, so always round up. So the quota here is 14 votes. So the way we would write this system is like this. 14 votes to pass anything. Player 1 has 8 votes, player 2 has 7 votes, player 3 has 3, and player 4 has 2. So here is the shorthand that describes this entire system. Okay, so suppose we change the quota to 10 votes. Let's write out the notation for this. Here was the old notation, 14 votes to pass anything, 8, 7, 3, 2 are the players' weights. Well now, notice that the 14 has just been replaced with a 10. Okay, that's all that happened there, right? There used to be a 14 here. Now the 14 has been replaced with a 10. Um, the reason I'm showing you this, among other things, is that there's a problem with a quota that's this size. So imagine that the motion on the table is legalize marijuana, yes or no, right? Suppose that these 8 people and these 2 people want to legalize marijuana, okay? Let's just suppose that's the case. These 7 people and these 3 people do not want to legalize marijuana. Well, if this motion comes to the floor, all you need is 10 votes for this motion to pass, right? Legalize marijuana, yes. These 8 people and these 2 people would vote yes. So the motion would pass because it got 10 votes, okay? Suppose now that a new motion comes to the floor, and that new motion is, should we not legalize marijuana? Should we criminalize marijuana? Well, these 8 people and these 2 people would vote against that, right? Because they like marijuana. But these 7 and these 3 people would vote for it. And if all you need is 10 votes to pass, then that motion would pass. Okay? So then you could bring another motion to the floor that's, hey, should we legalize marijuana? And then it would pass. And then not legalize, it would pass again, right? So the legal status of marijuana would just ping pong back and forth between these 2 groups of players that each can pass something. So the technical term for this situation is anarchy. Okay, so what's going on here is you get contradictions in the system all the time. Should we pass this? Yes. Should we not pass this? Yes. Because the quota is too small. Okay, so with a quota this small, you can have this ping-ponging effect of motions passing and then not passing, or their opposites passing. So notice what causes this anarchy. Let's point out that there are 8 plus 7 plus 3 plus 2. There are 20 votes in the system, and 10 is smaller than a simple majority. Okay, a simple majority means more than 50%. And 10 is exactly 50% here. So if you want to avoid this sort of anarchy, you need this 10 to be an 11 or bigger. You need this quota to be a simple majority or bigger. If the quota is smaller than a simple majority, then you will get the problems I just described. You will get contradictions all over the place. You'll get motions passing and then their opposites passing. Okay, that's bad. That's chaos. Okay, so now let's consider a parallel example. We do the example we just did, but now we set the quota to 21. So it's the exact same players, right, 8, 7, 3, 2, but now we replace the 10 with the 21. Well, as we just pointed out, there are only 20 votes in the system, right? So what would it mean to set the quota to 21? Well, it means that nothing could get passed, right? If you need 21 votes to pass something, and there are only 21 votes in the system, there's nothing that could ever pass. You will never achieve 21 votes. And the technical term for this situation is gridlock. Okay, so anarchy is bad because you can have motions and their opposites simultaneously passing. Gridlock is also bad because nothing will pass. So for the rest of this chapter, we will assume that neither of those situations occur. Okay, so we're going to assume that the quota is no bigger than the sum of all the votes. That's what this inequality is saying. The quota is small enough so that something could actually pass, is what this is saying. Right? A motion has a possibility of passing. And to avoid anarchy, we're going to assume that the quota is big enough so that you need at least a simple majority to pass something. Okay, so we're going to assume the quota is big enough that it's a simple majority, but small enough that you at least have the possibility of passing things. Okay, so the quota we'll assume is within that range. Okay, so in this previous example we just did, there are 20 total votes in the system, so we'll assume that the quota must be 20 or smaller so that something actually can pass. But we'll also assume that you need a simple majority, and 11 is what you start with if you need a simple majority. So in this particular voting system here, where these are the 4 players, we're going to assume that the quota lives between 11 and 20. So we're going to assume that 10 is just not possible. And we're going to assume that 21 is not possible. That would not make any sense. Okay, so that's what I had to say about the quota. So the quota needs to live in certain ranges in order for something to either be able to pass or for a motion to pass and not have its opposite also pass. So now let's examine some power issues of players. So here's a system in which there are 4 players. The first 3 players all have 10 votes, and the 4th player has 9 votes. So my question to you is, what kind of power does player 4 have? And this is kind of a problematic question because I haven't defined what the word power means, but let's just sort of intuitively talk through this. Let's suppose that player 4 doesn't want a motion to pass. Okay, so again, let's think about legalizing marijuana. Let's suppose that that's come to the floor. Suppose player 4 doesn't want that motion to pass. Can he stop that motion from passing? Well, no. These other 3 players, if they want to, they can gang up on player 4 and pass that motion. So if player 4 doesn't want marijuana to pass, he can't do anything about it because the other 3 can pass it on their own. Suppose, though, that player 4 doesn't want that motion to pass. Okay, if he doesn't want that motion to pass, can he do anything about it? Well, unfortunately, also no. There's really nothing he can do. These first 3 players have actually all the power. So the only way that a motion can pass is these 3 guys all vote the same, right? That would pass something. Or all 4 players vote the same. That's the only way for something to pass. So suppose that player 4 and player 3 and player 2 all want something to pass. Player 4 cannot swing that. Player 4 can't make the motion pass. So it turns out that if a motion is going to pass, it entirely depends on the opinions of the first 3 players. Okay? That's the point of this example. The first 3 players determine entirely whether a motion passes, and player 4's opinion is irrelevant. If he wants something to pass, it doesn't matter. If he wants something to pass, the only way to get something to pass is like this, the first 3, or like this. Okay, so if player 4 wanted something to pass, it would have passed anyway, right? The first 3 players are enough to pass. If he doesn't want something to pass, he also can't do anything about it. The first 3 players can pass it if they want to. So player 4 has no power. Yeah, so here's just a summary of what I said. There are only 2 ways for a motion to pass. All 4 players can vote for it. And in this case, if player 4 decides, oh, I don't want it, it doesn't matter. The other 3 players can still pass the motion on their own. The only other way for a motion to pass is for the first 3 players to pass the motion, and player 4 doesn't matter there either. So, player 4 has almost as many votes as the other 3 players, but his opinion is irrelevant. It doesn't matter what he thinks. The first 3 players decide everything on their own. Yeah, so the success or failure of a motion doesn't depend on what player 4 thinks at all. Okay, so here's an opposite extreme. So consider this system where you need 12 votes to pass, and player 1 has 13 votes, and players 2 and 3 have 6 and 4 votes. What kind of power does player 1 have? Well, if you only need 12 votes to pass something, and player 1 has 13 votes, then player 1 can pass anything he wants on his own. Player 1 does not need player 2 or player 3 to pass something, right? Furthermore, player 2 and player 3 don't have enough power to pass something on their own, because 6 plus 4 is 10, which is smaller than 12. So in the system, player 1 entirely determines whether something passes or fails on his own. So the technical term for player 1 in this situation is a dictator. He has all of the power, and the other players have no power. And in the setting in which we're going to be doing these problems, a player is a dictator if and only if his weight is bigger than or equal to the quota. If a player has a weight that's big, then he has all of the power. So here's a question to think about. Is it possible for a system to have more than one dictator? The answer sort of should be no, right? It wouldn't make sense to have co-dictators, but think about why that's true. Okay, so one last little issue with power here. Let's consider this system. The quota is 12, and player 1 has 9 votes, player 2 has 5, player 3 has 4, player 4 has 2 votes. What kind of power does player 1 have? Notice that player 1 is not a dictator, right? He has 9 votes, and it takes 12 votes to pass something. So player 1 cannot unilaterally pass a motion, right? He cannot single-handedly force something to pass. Player 1 is not a dictator. But notice this. 5 plus 4 plus 2 is 11. And 11 is smaller than 12. So these three players actually don't have the power to pass a motion on their own. Okay? So what does that mean? That means that player 1, his support is needed for any motion to pass. Okay? So he cannot pass something on his own, but he can force something to fail on his own if he wants to. So he can't force a motion to pass, but he can force a motion to fail. These three people, these three players here, they do not have the power to pass a motion on their own. They need player 1. So any passing motion must have player 1's agreement. The technical term for player 1 in this case is that he has veto power. So he's not as powerful as a dictator. He can't force a motion to pass, but he can force a motion to fail. Okay, so that is all the setup that we need in the introduction, and next time we'll move on to a definition of what power actually is.